This is a video from the exam 4 review. I'm going to take a look at problem 1. Suppose we have the summation from n equal 1 to infinity of n over 5 to the n times x to the n. And I'm going to apply the ratio test. We're looking for the interval of convergence. So I'm going to look at the limit as n goes to infinity of the absolute value of n plus 1 divided by 5 to the n plus 1 times x to the n plus 1. And I'm going to multiply this by 5 to the n divided by n times x to the n. So everything is an absolute value. So this is the limit as n goes to infinity of. Now I'm going to write this in a very systematic way. I'm going to write this as n plus 1 divided by n times x to the n plus 1 divided by x to the n times, and then I have 5 to the n over 5 to the n plus 1, like so. Now, this is equal to the limit as n goes to infinity of the absolute value of n plus 1 over n times. So x to the n plus 1 over x to the n reduces to x. And then I'm going to multiply this by 1/5. And so this is 1/5 the absolute value of x. This series converges when 1/5 the absolute value of x is less than 1, or -5 is less than x, which is less than 5. Now, don't forget, we have to test those endpoints. All right? So I'm going to check x equal 5. If I plug x equal 5 in, we have the summation from n equals 1 to infinity of n times 5 to the n divided by 5 to the n, which is the summation from n equal 1 to infinity of n. This series diverges by test for divergence. Okay. Now, for x equal -5, you get the summation from n equal 1 to infinity of -1 to the n times n. This series also diverges by, and we could also say test for divergence. That's fine. Because if I take the limit as n goes to infinity of -1 to the n times n, you're not getting 0. Okay? And so, what's my interval of convergence? Well, my interval is -5 to 5. My radius is just 5. And that's how you do problem 1. Let's take a look at problem 2. Suppose we have the summation from n equal 1 to infinity of x to the n over n factorial. And I'm going to apply the ratio test. So I'm going to get the limit as n goes to infinity of the absolute value of x to the n plus 1 divided by n plus 1 factorial times n factorial divided by x to the n. Now, this is the limit as n goes to infinity of. So I get x to the n times x times n factorial divided by n plus 1 factorial is n plus 1 times n factorial times x to the n. Okay? The n factorials cancel, the x to the n's cancel, and we get the limit as n goes to infinity of the absolute value of x divided by n plus 1. That's equal to 0, which is less than 1 for all x. Okay? What does that mean? My interval of convergence is negative infinity to infinity. It's going to converge no matter what you choose for x. My radius ends up being infinity. And that'll do it for this video. We looked at the exam 4 review problems 1 and 2. Thank you.